So we're gonna head out. Like first up, it start off with maybe say this item, the 14, and then whatever you see on the left side, I feel that it's gonna be larger than 19 is bigger than 14, 21 bigger, let's say 65, 30, 16, 19, 68. As you can see, left descendants all bigger than 14, right descendant are all more than 14, and it sort of like do the recursive function. So if we were to actually put it in another words, is that operation Z is whereby your sort of like left children, it's bigger, like your right descendants is also bigger. So if we were to actually put it in other words, you sort of like go recursive. So you go to 19, you're gonna ask the same question, like my left descendants to be bigger than this guy, right descendant to be bigger than this guy. 21, 65, 30 bigger than 19, and 6. So I mean, operation X is to actually do a sort of like a recursive transverse recursive that's been brought over to the children. So I mean, you go to 21, you ask the same thing, the descendants 65, 30 bigger, cool. And then you ask Mr. This guy 19 and 68 is also bigger. So eventually everything just kind of like just obey the rule, in my opinion, and that's great. And another thing is talking about maybe say the structure property. From how I actually see, one of like the rule book under these guys are that I mean, you talk about having structure property is that everything has to be filled up. So fundamentally, we're just pretty much like talking about like having it being fully filled up. So fully filled up meaning that if say I don't have this guy over here, it's not considered that like the structure property is being fulfilled. So similarly, if I remove this guy, it also means that it's not fully filled. He has to fill up this guy, and this guy over here. And another thing is that I can't like in terms of like the order property, it's saying that like the items is being filled up from left to right. So this guy, this guy, this guy, this guy, this guy, this guy. So if you were to see like this guy can't be if say this guy is not here and I have this guy, this guy, this guy, it's not considered to be correct. And what we actually truly need is that if you want to fill up more, it's got to be filled up like this way from left to right. So I think that's the in terms of like the order property. And if we were to actually go on to actually talk about like how the arrays has been arranged, so the first index 0 is usually being shut down, and then we always start off with like the first node. So is this guy over here, Mr. 14, and if you were to see that it's been filled up left to right, left to right, left to right. So 14, 19, 16, 21, 26 is all filled up accordingly, left to right, left to right, left to right. And eventually, when you actually want to actually identify your children, it's very easy. So for 14, you sort of like multiply the index by 2. So 1 times 2, you get the left child. Right child, 2 times 1, 2 3, you get a 16 guy over here. And you see I want the right children for Mr. 16 is that I 2 multiply 6 7 68, sure I get a 68. And similarly, if I want to find my parent, I just make sure that I always round down. So for Mr. 26, I want to see who my parent is. 5 divided by 2, 4.5, 2, 2.5, round down, I get 19. Yeah, 19 is the children, is the parent. So as you can see, we can use this formula to actually find out. And so far, we don't necessarily have like a maybe say like a lead code question or rule book for ourselves to actually reference onto, but I'm just very curious on how this Mr. Heap guy, Mr. Priority Queue guy is gonna play out in the lead code questions. Yeah, I'm very much curious on how he actually gonna pan out, you know. So looking forward.